The second option to address the cylinder exactly is, I think, theoretically more, it makes more sense theoretically to me, but really it is theory. And to be very frank and honest with you, the mechanics I'm going to show you right now are just theory to me. I have not tried this on a patient. I've anecdotally heard of some patients who've been treated this way, but I've personally never seen any post-wear maps to see what it looks like. And so all this is possibly just more for discussion, discourse, for education, and hopefully at least it'll spur some ideas for you. So if we consider the patient's lenticular astigmatism axis 60, in this approximate meridian, the lens has a greater amount of power. So what we want to do is want to flatten the cornea in the same meridian so that it becomes induced with toricity in this meridian to counteract what is in the lens. And in doing so, hopefully the two will negate each other. So to kind of set things into motion, we want to create an oval treatment zone, and we only want to do it in this meridian. So I'm going to set our adjustment to 50%. I'm going to go to this 135 meridian here, and I'm going to change the size of the OZ from 6.2 to 5.6. Now I'm trying not to change the curvature, I'm just changing the size of it so there's no vertical movement of the control point. And then the IC I'm going to reduce from 6.8 to 6.2. Okay, because we are designing in free-form mode, we need to go to the opposite meridian and do the same thing still in 50%. 6.2 to 5.6, and 6.8 to 6.2, at the same time leaving the vertical adjustments at the same place as they were originally. So now if you go through the meridians, you can see that the treatment zone is oval, slightly larger in this meridian, and then as we swing around, it's smallest in this meridian here. Now this is the left eye, and we see that we have 3/4 of a diopter residual cylinder. So what we want is about 0.75 diopters more power in this meridian. It's going to flatten the cornea by approximately that much, and hence in this meridian it'll be 0.75 diopters steeper with induced toricity. So if I go to the original lens, we see in this meridian we initially have 1.2 diopters of power. An additional 75 would put us about 1.95. By simply shortening the treatment zone, we actually are pretty close to target. But I'm going to bump that up a little bit at the red dot, as close to 1.95 as possible. And then the same thing on the other side because we're in free form, and it's already pretty close there. So now we have an additional 0.75 diopters of power in this meridian, creating hopefully or ideally a cornea with 3/4 of a diopter of toricity that is in exact opposite orientation to the lenticular astigmatism. Now, all this sounds in theory pretty good, but one of the struggles I think we're going to face is how do we keep this lens in that perfect orientation so that this meridian always is in this meridian on the eye. And I think with a corneal toricity of only about slightly less than half a diopter, there's very little mechanical force to keep this lens in place. In other words, it may very well rotate quite freely, and we're going to be inducing cylinder not only in this meridian, but perhaps in many other meridians on different days, depending on how the patient puts the lens on. Now, one way to possibly stabilize the lens is to add a prism ballast, kind of like we would stabilize a front surface toric gas perm lens or a soft toric lens. And the way to do that is to trick Wave into putting some prism in there. Now, Wave will not put any prism ballast into the lens unless there is a cylindrical over-refraction. So if you go to the over-refraction button and you add in -1/4, you'll see that the prism checkbox becomes checked. And if you hit continue, now we can see that on the front surface we've got prism ballast there. And looking at the back surface power, you can see the toricity that we induced in the lens by changing the treatment zones. Back to the over-refraction, it really doesn't matter what axis you have. -1/4 is the smallest amount. And all this does is it changes the front surface optics on the lens. So it may affect the patient's vision with the lens on, but it'll be minimal. And all we're doing is we're adding that in there so that Wave puts prism ballast on the lens. Now, the lens will hopefully orient to a particular direction and keep everything the way we want it to, but then again, we consider that this is a lens that is worn while the patient is sleeping, and most patients are not sleeping in an upright position where gravity pulls the prism ballast straight down. So what happens if the patient lies down on his side or her side? Is the prism ballast going to shift under the closed eye to a horizontal position? I don't know, and that is one of the challenges that's going to make this idea, I think, difficult to implement. Could the patient possibly just wear this lens while awake for a week and induce stable toricity to the cornea, at which point perhaps a diopter and a quarter of corneal toricity can keep a non-ballasted lens in place? These are all just ideas and theories, and I really don't have the answer to them. And this is one of the reasons why I think this is going to be a challenging case to complete. But those are my ideas. We can either over-refract or over-correct a patient slightly, or we can try tackling the cylinder, the lenticular cylinder, by inducing corneal cylinder. And again, this second strategy, it theoretically sounds good, but it does have many practical challenges that it faces. If I were to order this lens where we're trying to induce corneal toricity, one thing I would definitely do is in the orders box, leave a message for Wave indicating that I would like to have a dot at the 6 o'clock position. And what this does is it helps me see how the lens is oriented on the eye, and see how stable the lens sits. It's going to be counterproductive if the lens rotates significantly on the eye, because we're not going to get a consistent toricity to the cornea, and this will probably be a helpful indicator if you decide to go this route. So in either case, these are two options. Hopefully that the ideas we discussed are helpful and that you may have spurred you on to some ideas of your own. Both of them, like I said earlier, the prognosis for success, I think, is quite guarded. It's going to require some fair amount of patient education, and perhaps the best solution for this patient could be just part-time glasses for near work. But at any rate, I wish you the best with this patient, and thanks for watching.